So we end up with this tangent of 21.8, etc. Keep it in your calculator. You don't have to write the whole thing down, obviously. So at this point, are we ready to solve, having tangent? Let's plug in numbers and see what we get. Well, you know what? Actually, there are ways to simplify this, too. So delta y equals, if we multiply this first chunk, we get sine theta vi delta x over cosine theta vi plus, and let's multiply this other piece across also, remembering that, of course, we can put the squared inside. We just have to remember now that we have to square the cosine also. So we can do that. That gets us a delta x squared over 2 cosine squared theta vi squared. So what are the first things you can do to simplify here? Who sees something that can be canceled? Vi in the first expression. The reason that I'm encouraging you to look for these things is we'll get into problems where, oh, they don't give you a Vi. Oh, they don't give you a whatever. And so you have to be able to manipulate it algebraically to look for places where you can cancel things out. Okay, so sine divided by cosine, we're not even going to get into trig identities, but at this point we have delta y equals sine theta delta x over cosine theta plus a delta x squared over 2 cosine squared theta vi squared. Okay. I don't see anything else. I mean, we could factor out a delta x, but there's really no point in doing that. So we're probably, there will be points when it is necessary. We're probably at a point where we can plug in and go. So we should have something that looks like that. Be really careful with your signs here. Remember that you're going to end up adding a negative. Raw answer for delta y? What do you have? Go. You don't have a raw answer. You were just BSing me. Okay. We've got this for a delta y, 3.77 meters. What does that mean in terms of answering the question? So it means that at 10 meters, that is the amount of change in the position on the y-axis of the dart. So if we take this whole thing, copy, blow it back up, the dart ends up, this is the 1 meter mark, the dart ends up, this is the 5 meter mark. Of course, we're treating the monkey as a point, which it's not. But the dart ends up 4.76. How many sig figs do we have? 3? Yeah, we have 3 sig figs. So the dart ends up at 4.76 meters above the ground. Now the other question is, does it hit the monkey, which I don't really care about. That's the least interesting part of it. How would you figure out where the banana is at that same time? You'd have to solve for time. At what point in time is the dart here? And then you'd have to use kinematics equations to just do straight free fall for the banana. That's an easy one. I mean, the punchline giveaway, yeah, it hits the banana. Oh, isn't that cute? I don't care. The banana's very sleepy. But these are really what you're doing, is looking at a whole picture and solving for these. Even if you are not completely done with horizontal projectiles, I want you working on these today. I'm going to give you a packet probably at the end of the day today, but I want you working on the book problems for this. 1 through 5 on page 104. Okay. 1 through 5 on page 104. That's it.